Okay, something about myself. Now, I have over 15 years of professional work experience with a diverse profile and a broad skill set in the technology space. I have a degree in electronics and telecommunications engineering from Mumbai University and have over time worked in various roles across the telecom and financial services industry. My core specialization is in banking, cards and payments, telecom. I have led projects in complex IT transformation programs for large global organizations. These programs have involved full lifecycle project management and included manual automation, non-functional testing in either waterfall or agile setups. I have also been accountable for financial management, budgeting, forecasting, tracking, SLA commitments, and pre-sale support. I have managed multiple vendors and stakeholders, built and led multicultural, multifunctional teams, and driven customer satisfaction. Thought leadership, governance over multiple projects across portfolios, providing guidance and support to projects, and the use of processes, tools, technologies have been some of my key responsibilities as well. Since returning to India a couple of years ago, I've been involved in the startup ecosystem as a mentor and investor. This has given me great exposure to emerging trends, new technologies, innovative solutions, business models, all during the course of the due diligence process for investment deals. I've also done a certificate course in corporate directorship conducted by IOD Global. Through this, I've picked up some really great knowledge on corporate governance and financial health within companies. I'm also currently doing an online postgrad diploma course in data science through IIITB, as machine learning and AI greatly interest me. I believe the overall experience I'll gain would prove to be a real asset to my career. Why do I want to switch to analytics? Now, I think from a business perspective, enhancing the retail or the customer relationship is quite a key factor for me. Analytics is an added value to any organization that allows them to make these informed decisions and provides the biggest edge over competitors. So, adopting data analytics as a career move increases the chances of becoming a part of the key decision makers for an organization. So, that's another sort of factor for me. Other than that, it's multi-industry, multi-domain opportunities, and it's the most in-demand profession, and it has very competitive remuneration packages. What have I learned in my PGDDA course? I mean, we had a vast curriculum covering statistics, machine learning, neural networks, big data. We also did a capstone project in the BFSI domain. I've learned tools and languages used for data analysis are Excel, SQL, Python, Tableau. Had But I think the most learning was by working hands-on on case studies and assignments, etc., etc., which was a big plus for this course. My favorite project from the program. I think my favorite project was the HR analytics case study that we applied the principles of logistic regression. Now, the objective of the case study was to help a company identify current employees that are very likely to leave and recommend ways for the company to decrease its attrition level in the future. So we collected a total of 24 variables from 4 different data sources that were used to predict the probability of an employee leaving the company in the next year. Now, logistic regression measures the relationship between the categorical dependent variable and one or more independent variables by estimating the probabilities using a logistic function. Now, the model was built in R using the GLM function, and stepwise variable selection based on AIC and backward selections algorithms were used for variable selection. Variables which are significant, which is the p-value less than 0.05 and having low VIF, which is the variation inflation factor, were chosen, ending with the most significant variables having low VIF. Age, the number of companies worked, training times, years since last promotion, years with the current manager, environment satisfaction, job satisfaction, business travel, marital status, etc. were some of the variables which were the key indicators or predictors of the attrition in our model, or they were the final indicators. Now, this model was able to correctly identify 71.57% of the employees that were likely to churn. It had a sensitivity of 70.89 and a specificity of 71.7. So, overall, it was a very good model. Lift was 1.98, which meant that our model is 1.98 times better than at catching attritions than a random model. Then, why the K statistic attribute, we determined that it would be beneficial to target 50% of the employees ordered by the probability with which they are likely to churn, as it will capture 76.53% of the employees that are likely to leave. So, finally, based on the model, we recommended that the company should right away look to providing an employee friendly work environment, ample growth opportunities for deserving candidates, sufficiently longer tenures under the same manager. Also, look at younger, less experienced single employees who have switched jobs frequently and ensure their needs like salary, perks, trainings are addressed, and ensure adequate rotation of employees who need to travel for business needs so that the fatigue does not set in and work life balance is maintained. What are the typical steps or checkpoints in a data analytics project? I think the first step is the problem statement or the definition. So, understanding the business problem well is the most important factor so as to ensure that we move in the right direction. Like any other project, analytics projects also have tight release dates. So, business problem will tell us exactly what the issue is and what we are going to resolve in alignment in the business context. Data crunching or exploration. So, data familiarization and exploration is the next important step to follow. Once we've understood, the third step is information building. So, once we've understood the data well, we need to go to some data modeling. So, this will be an exhaustive exercise in which we'll identify the missing links and apply data modeling techniques. We must be quite familiar with certain terms like, data massaging terms like outliers, variables, regression, etc. Then there is the actual modeling phase where we do the data crunching and the data building. After we do the data crunching and the data building, in this phase we follow a technique in a repeated manner. So we'll have multiple iterations of running a model, evaluate the results, perform some calibrations and rerun and observe till we reach a satisfaction level from the results perspective. The next step is the validation or confirmation. So we have the final set of shortlisted models which have to pass the validation process. So here we'll put a fresh set of data in the data model built to ensure that the model is not specific to previous data or it has not really rote learned the data and it holds good to produce a similar kind of result. Finally, it is the deployment and monitoring. Once the final model is shortlisted, the best one is chosen and deployed and the results are kept monitored. So monitoring of results is important to check that the model behavior in real life scenario and do changes and updates from time to time. Now, why do we need to perform data cleaning? I think one of the most important reasons are to remove or filter all the inaccurate, incomplete or unreasonable data in order to improve the data quality. For example, data cleaning can involve transformations to correct wrong data, such as by transforming all variations for a date field to a common format. It can be associated with missing data and noisy data and removing or massaging the data accordingly. What is model overfitting? Is it undesirable? And explain with an example. So overfitting is the production of an analysis that corresponds too closely or exactly to a particular set of data and may therefore fail to fit additional data or predict future observations reliably. Now, the main goal of any machine learning algorithm is to predict the behavior on unseen data. Imagine if we have a self-driving car and you've trained it on every street of City 1. Then one day we go to City 2 and this car would maneuver properly with the acquired knowledge from City 1. So I may say, okay, now let me train my car on City 2. But what's going to happen with City 3 or City N? So in a theoretical sense, if an infinite amount of data is available, then all classifiers will work similarly. So basically you don't need machine language in the first place. But real world is different and it's not actually possible to exhaust all the data options. So we need an algorithm that can learn good models from existing data and it can work on unseen data. So sometimes overfitting of models is desirable when we are using, say, ensemble models. So this assumes that we have different models that overfit in different ways, and when aggregating these uncorrelated predictions, you reduce the variance of these very flexible low bias models. But I should add here that the base models are overfitting slightly and they're not just simply memorizing the data. So you just let the models overfit more than you would if you were to only use a single model. So that's an example when you could use you could do with a bit of overfitting. Now, how do you decide if the model developed by you is good or not? Now, what is considered a good model depends on the particular interests of the organization or the business success criteria. And the business success criteria needs to be then converted to a predicting modeling criteria so that the modeler can then use it to select models. Now, if the purpose of the model is to provide highly accurate prediction or decision to be used by the business, then measures of accuracy will be used. And if the interpretation of the business is what is of more interest, then you have subjective measures of what provides maximum insight, etc. For example, for classification problems, the most frequent metrics to assess model accuracy is percentage correct classification. So we have metrics such as lift, gain, ROC, area under the curve, etc. Now for continuous valued estimation problems, metrics often used for assessing models are R-square, average error, mean square error, median error, average absolute error, median absolute error, etc. Now what is the difference between supervised and unsupervised learning with an example? Now supervised. Now if you are training your machine learning task for every input with a corresponding target, it is called supervised learning. So which will be able to provide target for any new input after sufficient training. So if the targets are expressed in some classes, it is called a classification problem. For example, is a tumor malignant or not? Is a male spam or a ham, etc. Alternatively, if the target space is continuous, then it is called a regression problem. Example, you want to predict age based on pictures. Unsupervised. Now, if you're training the machine learning task only with a set of inputs, it's called unsupervised. So you don't have any data labels. So you'll have to be able to find the structure or relationships between these different inputs. So most important unsupervised learning is clustering, which will create different cluster of inputs and will be able to add any new input in the appropriate cluster. Example, if you have to group a collection of genes by lifespan, location, etc. Or a non-clustering example, the cocktail party soundtrack, where you separate the voice tracks in a chaotic environment. Okay, how will you handle missing data? Now, based on the business understanding of the data, we can delete these rows if the numbers are insignificant and they don't actually impact the overall sample size. We can replace it with mean, median, or mode if the data is numeric, like age or salary, etc. We can assign it a unique category if the data is categorical. Or I guess the most complicated or the most time consuming would be to actually predict the values using some sort of a machine learning algorithm. So basically we'll handle missing data with imputation based on the business context or business understanding of the data. Thank you very much.